Hello, welcome to another video. Today I want to talk about a Java library called Tablesaw. Tablesaw is a Java library that helps you to process tables of data. So think rows and columns of data. If you're familiar with Python, you can think of this library as being the Java version of the popular Pandas library. Let's get right to it. I have here a Jupyter instance that I've configured to support Java notebooks. The way I configured Jupyter to support Java notebooks is by using this Jupyter kernel here. So what I'm going to do is I'm going to create a new Java notebook, and then I'm going to import the packages that we're going to need. Now let's have a look at the data that we're going to be processing. This is a data dump from a personal budgeting tool that I use. Each row here represents a payment that I've made, and the value of the payment is in this outflow column. And the payee here represents the merchant or the seller that I bought something from. And the category here means the budget category that this payment was categorized under or deducted from. So let's load this data into a table object. So now that the data is loaded, we can show the data pretty printed using the print all method. Now, if you only want to print the first 10 and the last 10 rows, we can do that using the print method. And print is what's invoked when we call table.toString as well. Now, what's cool about Tablesaw is that it tries to infer the type of each column. So let's print out the structure of the table using the structure method, which returns a table that describes the columns of the table. These are the columns, and as you can see, Tablesaw was able to infer the type of the date column. For the purpose of this video, I don't need all of these columns. So what I'm going to do is I'm going to remove some of those columns. And let's have a look at the structure of the table now. And as you can see, now we're left with only 5 columns. So now let's say that you want to save the state of the table at this point to a CSV file. So we can do that using the write method. Let's refresh here, and you see that now there is this new CSV file. So let's open that up. And as you can see, there are only 5 columns now. As you can see here, the delimiter used in the CSV file is a comma. So what if we wanted to use a different delimiter? Let's look at the code for that. So in this case, I'm writing to a CSV file as well, but I'm changing the delimiter to a pipe character. So if I open the CSV file again, now the delimiter used is a pipe character. So there are 2 important types of methods in Tablesaw: mapping methods and selection methods. So mapping methods are for transforming data, and selection methods are for filtering data. So each column type in Tablesaw supports a different set of mapping and selection methods. And this is what makes Tablesaw so powerful, in my opinion. Let's look first at mapping methods. So let's have a look at our data again. So you can see here that we have a category column. And what if we wanted all the values here to be in uppercase? We can do that in Tablesaw by simply using the uppercase mapping method. It's important to note that a mapping function returns a new column, but the original column in a table stays intact. Now let's look at selection methods. Selection methods in columns, together with the where method in the table class, allow us to filter rows in the table. Each type of column supports a different set of selection methods. Let's look at the easiest possible example. Let's try to filter this table by the category column, and let's try to find all rows where the category is equal to electricity. So table T here will contain only the rows that match the criteria. Since where returns a new table, the original table is unaffected. That covers the basics of mapping and selection methods. They are what makes Tablesaw such a great library. Now let's process our data further. As you can see, the outflow column, which contains the value of the payment, is a string. And the problem with it being a string is that I cannot perform numerical operations like summing the values up. So let's convert this outflow column from a string column to a long column. Now, ideally, the library would support something like a big decimal column because we're dealing with money, but unfortunately, it doesn't. So the next best thing is to convert the dollar value here to a value in cents and store it as a long. So first thing, let's create a new long column. Let's get a reference to the existing outflow column. Okay, so the first thing I need to do in this transformation is I need to remove the dollar sign. The second thing I need to do is I need to convert the value to a big decimal. And then what I want to do is I want to multiply that by 100 so that I get the value in cents. Then I want to convert that to a long value, and I want to save that to the new outflow to column that I just created. Okay, so now let's add this new outflow column to the existing table. And let's have a look at the new table so that you can see the transformation that we just did. Finally, since the transformation worked out, let's remove the old column and rename outflow2 to outflow. So now that we have a long column representing the value of each transaction, we can start performing numerical operations such as sum, min, max, multiply, square root. So let's take the sum of that column. Let's try also negating all the values in that column. Now, let's use another mapping function, this time of the date column type, to do some feature extraction. So what I want to do here is I want to extract the year and month from each value in the date column so that I can perform analytics on months rather than days. So let's do that. This is easy using the YearMonth method of the date column type. So now, as you can see, we have another column here called YearMonth, and it contains only the year and the month rather than the full date. So now let's do some analytics. First, let's try to find the merchant or the payee that I interacted with the most. So we can do that using the countBy method. So this output is not that useful because the count column here is not sorted. So let's sort that. So now, as you can see, the payee that I transacted with the most is this supermarket A. Now let's say that we want to find all the payments that I made that cost more than $200, right? So we can do that by using a selection method. So let's do table.where. And the column that we're interested in is, of course, outflow. And the selection method that we're going to use is called isGreaterThan. And we want to find all transactions where the value was more than 200. And remember that we converted this column to cents, so we have to add 2 additional zeros. Let's do some further analysis on where I spend my grocery money. So let's filter the records so that I only see my grocery related transactions. Now let's filter this further, and let's say I want to see only transactions with supermarket A. So I can do this by just adding an AND clause. Let's analyze this further. Let's try to find the supermarket which I spent the most money at. So this isn't very useful because the sum column here is not sorted. So let's sort on that column first. So as you can see, the supermarket where I spent the most money is supermarket A, followed by supermarket B. And finally, let's say that we want to see the amount spent at each grocery store by month. We can do that by first grouping by the YearMonth column and then grouping by the payee column. Now, the problem here is that the results aren't sorted by the YearMonth column here. So let's change that. So now we can see that in November of 2020, I spent the most at supermarket B and the second most at supermarket A. So that's pretty much what I wanted to show in this video. I've only scratched the surface of what is possible with this amazing library. Please comment down below if you would like to see more videos related to Tablesaw. Thank you very much for watching.